Thank you for this opportunity to present our study today. So neurotrophins have been implicated to have an important role in the development of various bladder pathologies, and that includes neurogenic detrusor overactivity. Recently, a publication came out indicating that BDNF, brain-derived neurotrophic factor, may have a protective effect on the development of neurogenic detrusor overactivity following spinal cord injury. Therefore, our aim was to determine whether a small molecule agonist to the TrkB receptor, which is the endogenous receptor for BDNF, could improve functional recovery following spinal cord contusion injury in a mouse model. So we utilized female C57 black 6 mice, which underwent a severe contusion injury at the T8, T9 level. The mice were allowed to recover for 14 days and then were given a subcutaneous implant of an osmotic pump containing either vehicle or LM22B10, which was delivered over a 2-week period at 5 mg per kg per day. The mice were then evaluated at time points up to 10 weeks post-injury. So we initially assessed voiding function by urine spot tests. We found that sham-operated animals would, during a 2-hour period in the metabolic cage, which was lined with a filter paper to catch the urine spots, would void in one region of the cage at 2 to 3 sites. Chronic spinal cord injured animals had multiple voids and much smaller volumes, which was scattered across the entire cage. And we found that LM22B10 treated animals tended to have larger void volumes and less urine spots. So then we went to evaluate the histological changes, and we found that the chronic injured animals had hypertrophied bladders with extensive collagen infiltration through the detrusor layer, while the LM22 treated animals tended to have less collagen infiltration. And this correlated with the wet bladder weights that were from these animals, where the vehicle-treated animals had larger bladder weights compared to the 22 treated, although still elevated compared to the sham. And then we also assessed the extent of inflammation as by looking at the mast cell infiltration. And there was an extensive number of mast cells present in the vehicle-treated animals, which was significantly, quite decreased in the LM22 treated animals. So then we looked at the spinal cord level at the contusion site. At 4 weeks post-injury, there was a significant amount of damage to the spinal cord region with extensive collagen infiltration to form a scar. And this disrupts the architecture of the spinal cord to prevent neuroregeneration. As you can see, the vehicle-treated animals have an extensive amount of collagen, while the 22B10 treated animals tended to have less collagen and more limited around the glial scar region. So then we next looked at the amount of glial fibrillary acidic protein, which is a marker for glial cell activation, and which is the cells that predominantly form the glial scar and inhibits functional recovery. The vehicle-treated animals had a much higher expression of the GFAP protein compared to the drug-treated animals, and this seemed to correlate with the expression of TrkB. And then to determine whether there was any neuroregeneration going on, we found that in the vehicle-treated animals there was an upregulation of GAP43, but surprisingly the 22 treated animals didn't really show a significant difference or even a downregulation. And sort of to correlate with the GAP43 data, we assessed the recovery of the hind limb motion, and we found that there was no significant change in the rate of recovery for the hind limbs in these between the vehicle and drug-treated animals. So in summary, we found that administration of a TrkB agonist appeared to improve the bladder function, decrease the amount of hypertrophy, and it seems to correlate with the decrease in collagen infiltration and inflammation. And this also was associated with a decrease in the glial fibrillary protein and TrkB receptor expression at the injury site. So we conclude that the LM22B compound may have a therapeutic potential for treatment of neurogenic detrusor overactivity or lower urinary tract dysfunction, and its mechanisms and sites of actions require further investigation. Thank you.
Great work. I didn't understand, in your abstract you say that you have an improvement of overactive bladder, and then you say that is improved the voiding function. Can you?
Well, we still need to obviously do the assessment of the bladder function as in cystometry and EMGs, but we initially just looked at it as whether the mice were voiding better, whether they were able to hold more urine and actually not spot across the entire cage and have less frequent voids. And that was our initial assessment of this. Okay. So I know I have to be very careful with my terminology.
Thank you. First.
Yeah, I was just a little troubled that you were using the term significantly a lot to describe differences, yet I saw no statistics, and some of the ends were like 2.
Yes,
so,
no, the inflammation part was just something that we threw together. I wouldn't say it's not publishable, obviously, yet. So
yeah, was there anything that was statistically significant?
I would say it's just the bladder weight that. But even then, I'm not too thrilled with the numbers that we got because contusion injury is highly variable.
Right, no, I agree. But I mean, did you run statistics? Did you do an ANOVA on it?
Yes, I did an ANOVA on the bladder weights, I think. Yeah, that was the only thing that came out. Everything else, I haven't actually quantified the collagen infiltration yet, and I haven't done the, obviously the mast cells are nowhere near ready for running any sort of statistics on it. Yeah.
Chris Payne, California. Your protective agent, you give it 2 weeks rather than right after the injury, and can you tell us just some insight into that decision?
Well, the paper that I was basing the study on, which was Francisco Cruz's study looking at the effect of sequestering either BDNF or administering BDNF. I believe he gave the BDNF after the injury, and I was actually more interested in whether it could rescue any sort of functionality of the bladder or hind limb locomotion. And I think that would be more sort of pertinent, at least for people with injury, rather than giving something you can just give before or right at the injury, when you may be working with a time window that you can't kind of meet.
Thank you very much.